Hi, this is the this is section 13 13.3, and this is the video general for the advanced manufacturing final report.
All right. In lab one, we have delved into MATLAB simulation, creating a rigid body tree model for a robotic arm. We explored a forward and inverse kinematic crucial for understanding robotics movement and control. Visualizing this movement help us to grasp complex concepts and laying a strong foundation for our subsequent robotic studies. And in our lab two, we have using program the robotic arms to detect and pick up color blocks using IR sensor. And then we have utilize the P2P measurement command to calculate the distance and angle between the objects, enhancing the precision in robotic operation. And in the last tech, we have utilized image processing technique to detect the color of blocks, sorting them with the robotic arms by converting image to two coordinates. And here is our test 3 videos. As we can see in this videos, the robotics only pick up the yellow blocks. Yeah, and then in lab 3, we have the teams can coordinate as two Dubai robots to transfer a color block from a starting point to an endpoint. And here is the video for the task. As we can see, the two robotics is using the input-output programming language to do the testing. And in the second text from lab 3, we have using vision guide rectangle matching. We use vision assistant to identify and place rectangles in specific templates, showing case skill, image processing, and robot manipulation. And here's a video for text 2. As we can see here, that the robot is identify the rectangle shape and then put it into the correct templates that's desired. And then moving to the next, we're gonna talk about what is our method to do the final task.
So the final task was something that we had to use all the stuff we had learned from the previous tasks to do. So we broke down the final project into two portions, the receiving end and the sending side. The sending side must identify each letter that will be needed for the puzzle, deliver it to the other team, and then send them a signal so they know to go get it. Pieces were identified through blob detection using color and preloaded images of each letter to identify the puzzle pieces in the group. Then it picks one up, the order is not specified, places it at a location between the two robots, and then returns to a neutral home position out of the way of the other robot, and then sends it a signal to the other robot using the IO output function. We use the 1 as the on signal. Then, as for the receiving side, the process is made up of signal reception, piece identification, identifying the correct place in the puzzle, and the piece placement. Once the robot receives the 1 signal in the IO input function, it begins the piece identification process. Using FastMatch, the robot has stored what each letter should look like in a particular lighting, and then picks it up. Once it has picked it up, it uses its piece identification to look for what puzzle opening it should go to. Once it identifies the correct puzzle location, it uses shell module to adjust the piece's current angle to match the puzzle piece angle. It then places the puzzle piece and, like the previous part, moves to a home position out of the way of the other robot. This is the demonstration of how that looked.
Here is the pig puzzling. Oh, this is the dog puzzling. And here, this is the pig puzzling. And that's all for our final demonstration. Thank you all.
Thank you.
And, I gotta stop the recording.